Welcome. Today I'm going to show you these miraculous 3D prints I have created as projects. So, one of my first 3D print was this cup. I made this in Mathematica. The whole thing was designed with mathematical functions. So, it is a disk over here, and this connects with some intersection area to the thick surface that is this vase side. And as the radius, I had a little help from AI, but it came out to be 1 plus the cosine function approximately. So you can see it has a lot of dimensionality to it. It's quite 3D. Again, one of my first prints. Here's another mathematical piece I did, and I realized that I could take an equation for the unit circle and just add the sine function as a height. Again, so there's a parameterization, and then the height reveals this wonderful shape. Here is a political piece. I had made this before in metal, but I got the chance to try it out in plastic. And this says Ghana and USA sandals, and the sandals are kind of a metaphor for the comfortable nature of the trip when I was a study abroad student there. And then E and H is my first and last name. And there you have it. So moving on a little bit here, this is a nice 4-color design. It prints pretty quickly. And you can see that the back is not just one layer, one piece. It's got at least, it's got 5 sub pieces. And this was a lot of fun to make. It is origami inspired. So I had an origami design that's almost identical to this in structure. And then I came at it with the plastic. So here's a slightly larger version of the political piece. And I added Bodoni ornament type font flowers at the corner. And then I've got positive and peace on earth. It just brightened up the new words, made the piece a little bit more approachable. So again, going back to Mathematica, this is one of my all-time absolute favorite mathematical constructions. And what I did is I took a parabola, and then I calculated a helix that went around the parabola, and then another helix that went around that helix that goes around the parabola. And it came out really well. It still has some support material. This is where I removed it. It took a little too much time to take off the support material, but you can see that it is quite extravagant. And really, I think of this as a work of genius. Here is another mathematical surface, and this is across from left to right. This is a sine wave. I can't immediately describe the surface without giving the equations, which would be a little bit cumbersome. But basically, if you look at it, it has these nubs, and that's because I fused another surface called the egg crate surface, and that has a surface like an egg crate, and I multiplied the height value of the egg crate surface against the surface normal of this sine wave surface, and that gave me what you see. So it's quite complex mathematically and follows a very interesting pattern. Here's a slightly different one where you could say that horizontally I have a sine wave, and then in the opposite direction I have another sine wave. One wave is quite smaller than the other, but so this way is the big wave, and then this way is the small wave, and then this is all done by equations in Mathematica. There was no fudging it or using proprietary programs. It was all done from scratch using equations. Here's another smaller version of the helix on a parabola. And you can see that actually the level of detail is quite high. So here is a big art piece that I designed for 3D printing, and I'm calling it Cool Twist. Basically, it's got these artistic structures on the left and right, but in the center, it has a Mobius strip of 9 twists. So that's interesting mathematically because it all has one side. It's a one-sided shape. So the black Lego figure is enjoying the mathematics of the display, and this is something I would like to see in reality. Again, cool twist. And then this is the back, and there you have it. So I have a few more. I'm still going here. This is one of the interesting adventures I had with the AI bot Claude running Blender. So I imported this young man of a jack-o'-lantern looking face, and I gave it some thickness in Blender, but then I used Claude through prompts to help me form it into a box. I had to do the remaining work on forming it into a box, but Claude got me started on this. I could have done it by hand, but Claude made the experience so much more interesting and easy. It was very good. So there's the square shape, there's the box shape, and this is actually supposed to be a young man with beads in either dreadlock but some type of textured hair. here is the other shape I quickly put together with Claude on Blender. And Claude is the AI bot. And we've got a torus on the top, a sphere in the middle, and a tetrahedron on the bottom. So now finishing up here, I've got 3 line plots in Mathematica that I 3D printed. And this was an ellipse, but I calculated a helix that goes along with the ellipse parameterization. And it's pretty solid. It could be like maybe a bracelet. PLA plastic. So here I took that same helix on an ellipse and I added a helix on the helix. So if you recall, this is also done similarly. So there's a lot of differential geometry in these guys. And then finally, I did this gangly looking one by working with what's called the binormal on a shape. So these have just been some random 3D prints. I selected them using no logic or rhyme or reason. They were sitting around, and it gives you like a sample of the cool projects that I've been doing. It's all very fun to do, and I hope you enjoy 3D printing as well, and take the opportunity to even get yourself a 3D printer and begin the process. There's learning to be done. So Blender is a tool I use. Mathematica is a tool I use. Inkscape is the tool that I use before I import some of these objects into Blender to add an extruded thickness, things like that. So thank you for watching.